Hi, in this video I will introduce you to electric circuits and some basic definitions that are used in this topic. So first of all, let's draw a simple electric circuit. So it must have a source, okay, a cell, and I can put a switch with a bulb here. Okay, let's put a resistor over here. And let's put an ammeter, and over here we put a voltmeter. Okay, so this is a basic electric circuit, and you should label all the components that you used. Okay, now a current will flow when the switch is closed. So if the switch is closed, a current will flow from the positive terminal and go around the circuit to the negative terminal. So it would not go into the voltmeter because the voltmeter has a infinite resistance. So it is nearly infinite that the current does not go into the voltmeter. So the ammeter has a resistance which is near to zero, because this is due to the current not affected by the apparatus. So if the current is near to zero, so that it would not affect the current around the circuit. So the ammeter would give you an accurate reading. And the wires itself must be a perfect conductors, because a perfect conductors have a resistance of zero. So the wire must be insulated and should be a perfect conductor, that is, the resistance must be zero. So you see, an electric circuit consists of a source, which is the cell, and the cell is providing electrical energy to the system. And it must have also a load, which, for example, over here is a bulb, and the resistor. So what happened to the electrical energy? It is absorbed by the bulb and the resistor. Okay, because it does work at the load. And third, it must have a transmission system. For example, an insulated wire of perfect conductors. That is, the resistance of the wire must be zero, and lastly, it must have a control apparatus. For example, the switch can be on or off. So when you are not using the circuit, you must switch off the circuit to prevent heat loss or energy loss to the surrounding. And remember, the bulb here is providing light energy, but also heat energy is dissipated from the bulb, and it is known as wasted energy. Okay, so an electric circuit is just an interconnection of electrical elements okay, such as resistors and bulbs and so on, which are linked together in a closed path, so that an electric current can flow continuously around the circuit. And remember, the flow of current is due to the delocalized electron. So electron is flowing in the opposite direction of the current. So it is from negative to the positive terminal of the battery. So let's define a current. So current is defined as the rate of flow of electric charge past a given point. Okay, so this is a definition for the current. We can also define it as dq by dt, which is the rate of change of the charge. And also we can define it as the change of the charge divided by the change of time, because the current is flowing past a point. Okay, let's see, this is at time t is equal to 0. It passes here until here at t is equal to t1. Okay, so the charge has passed this given point at the time t1, and this is known as a current, the flow of charge per unit time. Okay, sometimes we define it as a function. So I is defined as a function of time, and this is dq by dt. Okay, and here I at t is equal to 0, or you can have I at t is equal to t1, and so on. So the current can be of two types. We can have direct current, DC, okay, which is of constant magnitude. It is a unidirectional current of constant magnitude. And also we can have AC current, alternating current. Okay, AC is for alternating current. Okay, this is like it has either a positive or negative. It is always changing with respect to time. Okay, we also call it a sinusoidal wave current, sinusoidal current, since it is always changing. Okay, so now you have to know about potential difference. Okay, so the potential difference is the work required to move a positive charge of 1 coulomb through the element. Okay, it is also called a potential drop or a voltage drop. So it is just a potential. Potential means from two different points. So we can also define this as dW divided by dQ. So this is the voltage as the potential difference or the voltage. So it is a change in work divided by the change in the charge. Okay. So now power is a rate of doing work. Okay. So the rate of doing work across the circuit. So the work is electrical energy itself. So power is also given by the voltage multiplied by the current I. Okay, and you can write it as. So the power is now the rate of doing work. So it is dW divided by dt. And the voltage is the work done divided by the charge. And the current is the charge per unit time. Okay, so this is related. So a source is either a voltage or a current generator that are capable of supplying energy to the circuit. For example, okay, a battery is a voltage source. Okay, sometimes we represent an ideal source is represented in this using this symbol or using this symbol. This is an ideal source. Okay, or a current ideal current source, we can represent it using just the arrow pointing in the direction of a wire or something like this. So this is the current source and this is a voltage source in an apparatus. So for example, if I put a load across an ideal source, an ideal voltage source, okay. So let's suppose this is 10 volt ideal source. So this is a load, and the load is of resistance of 1 ohm. So the current flowing around, okay, around this circuit would be the voltage divided by the resistance, which is 10 divided by 1, which is 10 ampere. So it is constantly supplying 10 amperes all around the circuit. What if we reduced the resistance? So if we reduce the resistance, we will get a bigger current, and the I would be 10 times, which is 100 ampere. If we reduce the resistance, we get a bigger current. Okay. So this is by the definition of Ohm's law, which is I is equal to V over R. If you increase resistance, you decrease the current, and if you decrease the resistance, you increases the current. So a dependent source is a generator that is dependent on another circuit variable. Okay, so a dependent source will represent it in this symbol. So this is for the voltage and this is for the current. So this is a symbol for dependent source. Now let's define resistance. Resistance is a physical property of an element or device that impedes the flow of current, usually represented by R, the symbol, and the unit is ohm. And therefore, if we want to define a resistance, so resistance is proportional to the length, okay, L, and it is inversely proportional to the cross-sectional area, A. Okay, so the resistance depends on the nature of the material, okay, or the sample, and therefore if we combine these two, we'll get that the resistance depends on the length and the area, cross-sectional area of the apparatus. So the length, which is proportional to R, but the area is inversely proportional. So we can just remove the constant, the proportion sign, and put a constant over there, and this constant, we introduce it, is called the resistivity of that material. And resistivity is in ohm meter. So this is the unit used for resistivity. Now, conductivity is defined using this symbol, okay, and it is 1 divided by the resistivity. So conductivity is in Siemens, so this is a unit per meter, Siemens per meter. And the conductance, which is given by the capital G, is 1 over the resistance R. So there are factors that affect the resistance of materials, such as temperature. A temperature rise will produce an increase in resistance, and a decrease in resistance of insulators and semiconductors. Okay, because it depends on the nature of the material itself. So a temperature rise would increase R in metals, but would decrease R in insulators or semiconductors or electrolytes. Okay, a resistor can be modeled by Ohm's law. So Ohm's law, V is I times R, resistance. Okay, so if I have a potential, okay, let's say that this is 1.5 volt. So this is a higher point, and this is a lower point. It is a potential, okay? So in the sense, the arrow goes up, and we say that the potential is 1.5 volt. In electric circuit, we also define a node. A node is a junction where 2 or more circuit elements are connected. For example, okay, I connect a bulb over here, and I connect a voltmeter here. So this is a node. So the point over here is a node, okay, it is a junction. A branch is that part of a network that lies between two junctions. Okay, and a loop is a closed path in a circuit. So this is a loop. It is a closed path. I can have another loop over here. This is another loop. Okay? So it is a closed path in a circuit in which no element or node is encountered more than once. Okay, you see, this is a circuit. This is a closed path. The node is over here, and this is another closed path, which is called a loop. And we also have a mesh. So a mesh is a loop that contains no other loop within it. Let's see how to count number of nodes and branches, loop, and mesh. So let's see a circuit, for example. We have resistors connected. So this is a circuit where we have resistor R1, R2, R3, R4, R5, and R6. So now we have to count the number of let's see, the number of nodes, number of loop, the number of branches, and the number of meshes. Okay, we have 1, 2, 3, 4, 5, and 6 nodes. Okay, so these are the nodes in the circuit. And we have the loop is 1, 2, and the bigger circuit itself is the third one. So this is 3. So we have 3 loops in total. So taking in consideration the smaller loops, and the bigger one also is a loop. So we have 3 loops. Okay. And now branches. Count the number of branches. So this is 1, 2, 3, 4, 5, 6, and 7. We have 7 branches. And for the number of meshes, we have 1. This is a mesh. Okay, mesh 1. And we have 2. This is mesh 2. So we have 2 mesh. Okay, now you know what is nodes, loops, branches, and mesh. Okay, now suppose from this circuit, suppose a resistance R6 is removed, then this would be open. Okay, this would be open. This part is open. there is an open circuit between these two terminals. Let's call it terminal A and B. So if now this resistor or 6 is replaced by an ideal wire with no resistance, okay, it is just a wire, the resistance is 0, okay, then there is a short circuit between the terminal A and B. So a short circuit is between the terminal A and B. Okay, now let's see how we solve problems in electric circuits. So two approaches for solving problems. So first one is a direct method. This is for simple circuits. We apply Kirchhoff's laws, loop analysis and nodal analysis, superposition theorem. And second one is network reduction methods. Okay, where we use the famous Thevenin and Norton theorem. Okay, this direct method is Kirchhoff's laws, loop analysis, and nodal analysis, and superposition theorem. So we'll see both approaches for solving some problems in electric circuits.